here BitmapFonts. Sometimes GTF fonts aren't flexible enough. Since rendering text is just rendering images of characters, we can use bitmap fonts to render text. Okay. So this is texture wrapper class, and we have load image pixel buffer, creates image, reload it. Okay. So what are the modifications? Get pixels, get pitch. Okay, in the previous tutorial, when we did texture pixel manipulation, we didn't care which pixel we got since we wanted to grab all the pixels. Okay. Here we need to get pixel at exact xy coordinates. Okay. Since which is why we're adding get pixel 32 function. Alright. So get pixels 32 and get pixel 32 selection get pixel 32 at x and y coordinates, returns a pixel at x comma y coordinates. Okay. A bitmap font. Okay, so I would need to create what is that? Bitmap font. Okay. Bitmap dot h and bitmap font dot c. Okay. Okay, so we define a bitmap. It contains the texture, an individual character in the surface, okay, and spacing variables, okay, new line and space. So we need the texture, then I need my font bitmap font, and the member variables are a texture, font texture, okay, so we have a font texture, then we have individual characters in the surface, STL, right, then we have STL, a rectangle, char, so 256, contains the coordinates of all the characters. Then we have spacing variables in space, comma, new line. These are spacing variables. Okay, so We have some functions: a default constructor, build font uh, from string path. Okay. Then we have add a render text function. Okay. So we have bitmap font. Create. Then we have generates the font, bool bitmap font underscore build font. BMP. And we have a path line. Path. And what this does is generates the font. And we have deallocate font. Okay, so it loads up the font. Okay, it loads up the font from a file. Loads up the font from a file. And then we have deallocates font. So I'll void destroy deallocates font. I hope. Hold up. Yep. Okay. Deallocates a font, and then finally I have a function to render it. I just need to check. It requires a window. Okay. So we'll go void bitmap font render. Then we need the position and the string. Okay. So I'll need BMPF. Then we need the window. I think texture contains the window. Yeah. Okay. Window, then coordinates and the string. Right, string, which is the text. Displays the text. Right. Okay, so here is a bitmap font which functions as a wrapper for a sprite sheet of glyphs. It has a constructor to initialize internal variables, a function to build up the font, and a function to render the text. When the bitmap font is built, we go through the texture and find all the character sprites for the 256 characters that are stored in, and calculate the distance for a new line and a space. Okay, So we have get pixel 32, we get the pixels, and then we get y into pitch plus x. Okay, so let me define this function. Okay, so let me define this function where r get pixel, get pitch 32, get pixels. We'll just fit it right here. 32. Text and get pixel 32. I hope I defined it that way. 32 texture and then x comma y. Okay. Okay, so we get a reference from the pixels. Pixels equals, I have these pixel surfaces, pixel surface dash pixel. Okay. So we go texture. Okay, yeah. Alright. Check. Then 0. Check texture should not be null. We have error invalid texture, and that is great. The error we return a 0. Pixel surface pixels, right? Pixel surface, I think, yeah, pixels surface, and then we pass in the pixels. Okay, and then we get the pixel requested. We convert the pixels to 32 bits. Okay, pointer of 32 bits, right? Okay. So convert the pixels to 32 bits. Then we have return pixels, y into pitch, y times texture get pitch 32, and we pass in the same texture plus x, right? Return the requested pixel. Here's the function to get a pixel. Y into this, yeah. It's a good idea to separate out a little bit. Y times pitch. Okay, here's a function to get a pixel at a specific offset. Okay, it is just like the addressing modes, right? If I want this, so I'll go up move, right? The important thing to know is that even though we have a two-dimensional texture image, pixels are stored in one dimension like this. Okay. So if you want to get the blue pixel in row 1, column 1, this one, you would have to calculate the offset like this: y offset into pitch. So pitch is 5 pixels per row. Okay, that is like pitch is basically the horizontal So plus x, uh, x comma y, right? Row 1 column 1. So this is 0 0, this is 1 0, and this is 1 1. So 1, so we pass in that we want to move this much, then at this, right? Okay, so we skip the rows by multiplying the y offset, and then we add the x offset, right? Y offset and then x offset. As you can see, the pixel at index 6 on one dimensional pixel is the same as row 1. Okay, so we have bitmap font, then we have build font. Alright, so this is equivalent of addressing modes in arrays. Okay, so we have rows. How many rows are there? Rows are depicted by y, I suppose, right? And then position of individual columns are given by x. So if I say 1 0, so it is row 1. No, see, if this is right, okay, this is 0 0 0 1, this is row, so 0, x offset, y offset. So first row column, calculate offset like this. Okay, so if this is 0, okay, so we pass in, we multiply by pitch. Okay, no, let me do a little. Okay, see, I have this right. Okay. Alright, so I have this right. Maybe I should I'll just go with bake. So there are, like, this is of size array of size, let's say 5. Okay, so 1 2 3 4 and 5. Okay, so we have an array of size 5 by 5, 5 by 5. Okay. So how does addressing, like, say I want to get this is 0 0 0 1 0 2 0 3 and 0 4, then this is 1 0 1 1 1 2 1 3 and 1 4. Okay, so what's the formula? It is, say, base address plus how many rows do you want to skip, right? How many rows do you want to skip? So the rows, which rows, which row is currently going is given by x, right? So no, the current row is given by x. So I go row into whatever the size of the row is. Okay, but this is not 5 by 5, this is actually a 2 by 5. We have 2 rows and 5 columns. 2 rows and 5 rows into, so okay, I can say that it is x into row size, right? X into row size plus the y offset. See, this is how it is done within a row. So if x is 0, then we have the offset of 1, so it will just address it. 0 is 0, so this, right? But what we have here is y offset into pitch, right? Pitch is basically, it says y offset is 5. Pitch is okay. Y offset, y represents the, okay, I'm silent 32, and okay, so go with silent 32. Okay. Still I am a little confused because, right, it should be other way around. X, because x represents the rows, right? Yeah, okay, but then we I'll carry on. Let's see, then we have bitmap font, new line is 0, space is 0. So okay, I should include bitmap font dot h, bitmap font, bitmap font underscore create. We'll have bitmap font temp equals malloc size of bitmap font, and we check temp should check check memory on temp, and set temp dash texture. Okay, 256. Default initialize. can I do that? But I'm not creating one. This is the default initialized, and this texture I cannot do anything about that. And then we have space, so I'll go space equals 0, and temp new line equals 0, right? And we return null, else we return temp. Okay. Then we have bitmap string. Okay, so get rid of the pre-existing. So how it's predefined, can it go? So I can define free render text. Nope. Okay, so we will put build font. Okay, bitmap to build font. So bool bitmap font underscore build font. Bitmap font underscore build font. Bitmap font BMPF. Then we have path. Okay, so we go. Let's get rid of pre-existing texture. Rid of pre-existing texture. Bitmap font underscore destroy. And then we have it should be free here. Okay, hold up. Okay, so I'll create a font. Destroy. So we'll call free. Then we load up the image in the path. Texture load from pixels, I think. Load pixels from file, right? Load pixels from file, yeah. Pixels from file. And what else do I need to load pixels from file? I need to pass in the window. Okay, so I also need to pass in the window. I think I should also fix this. Thing in render also, yeah. Okay. Now I will deallocate memory. Yes. So we pass in the texture, right? BMPF, address of BMPF texture, right? Then I pass in the window, and then I pass in the path, right? Load pixel from file, texture, window, and path. Check. R should be true. Error. Fail to load file at path. Then we go to now we're entering the function that's going to go through bitmap font and define all the clip rectangles for all sprites. Okay. To do that, we'll have to load the bitmap font pixels. Okay, get the background color. So we get the pixel. Okay, so that is the background color at 00. So we define get the background color. PC color equals texture get pixel 32, right? It's not pixels, it's get pixel 30. And you would have to pass in the texture for that. So BMPF texture and anything else 00. Okay, nothing. We get the background like this. Then set the cell dimensions. Okay. Okay, so each cell is 16 by 16. No, okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so there are 16. Cell width and cell height. Get. Okay, so new line, variable, top and base of A. The current character we're setting int current char equals 0. So in order for this bitmap font loading to work, the character glyphs needs to be arranged in cells. Okay. The cells all need to have the same width and height arranged in 16 columns and 16 rows, and need to be in ASCII order. The bitmap font loader is going to go through each of the cells, find the sides of the glyph sprites and set the glyph rectangle for the so we cell width into column. Okay, dot x. Okay, these are the position x and y. Okay, 16. So we have 16 rows and 16 columns. First we get the background color, which we will need to find the edges of the glyph sprites. Then we calculate the cell width and height. We have the variable called top, which will be keep track of the tallest glyphs in the sprite sheet. The variable base A will keep track of the offset of the bottom of the capital A glyph, which will be used as a baseline for rendering characters. Okay. Lastly, we have the current char, which keeps track of the current character. So you have the current char, which keeps track of the current character glyph we're looking at. Okay. Okay, so I can set cell dimensions. Go set cell dimensions. We have int cell width and int cell height. Texture get width of BMPF PF texture divided by 16. Texture get height BMPF texture 16. Then we have okay, so we are setting both the top and base equal to height. Okay, so new line variables. And top equals height and int base capital A equals cell height. Okay, then we the current character was setting. And we have and current char equals 0. Right. So we'll go through the cell rows, go through the cell columns, and set the correct offsets. Okay. Thus, and x equals number of columns, number of rows, position. Int rows equals 0, less than 16, less than 16. Yes. Okay. So we'll go through the cell rows. Set up the SQL rect for each of the characters. And row equals 0, row less than 6. What is less than 16? Row plus plus. And for int column equals 0, column less than 16, and column plus plus. Then we go chars, right? I have chars, so we'll go bmpf chars of current char dot x equals, we go we go row times cell width, and then y will be row times cell height, right? Okay, width is columns and cell height into rows. Okay, so that's how he has flipped columns and rows, column and row. That is why it is flipped. Okay, now I get it. Set the dimensions of the characters. Set the position of the characters. Then we have set the dimensions of the characters. BMPF chars current char dot width equals just copy this dot height, then we increment current char plus plus. No, okay, so then we have to find the left side. Okay, that's why it's columns, right? He has flipped it. Okay. Okay, so we are going within the cell. Now we are searching within the cell. We go through the pixel rows. Go through the pixel rows. So it should be going like that, but it is going through the columns. Okay, these two nested loops are going through the cell rows columns. At the top of per cell loop, at the top of per cell loop, we initialize the glyph sprite position at the top of the cell, and the sprite dimensions should be cell dimensions. This means by default glyph sprite is the full cell. Okay. The above assignment defines that the glyph, what is the word for spreads across the entire width and height of the cell. Then we find left side. Let's change that by finding the left, top, right and base. Okay, so we go find left side. We go through the pixel. Okay, so this is done for each, right? Find right side, find top, and then find bottom. Okay, find left side. So it go through the cell rows, go through pixel columns. Now we will loop within the cell dimensions, that is cell width times cell height. Okay, find left side. So we are just going through each row, then each column. Okay, this is man, it is okay, whatever. So for int recall equals 0 if it is column less than cell width equal plus plus. And for int p row equals 0, p row less than cell height, p row plus plus. Go through pixel columns, go through pixel columns and go through pixel rows. You get the pixel offset, cell width into column. Just be cool. Okay. Now we are fetching individual pixel within that cell. So int px equals cell width times yeah, you know, what happened to my convention, you know, private. Cell width time row column, cell width time columns multiply column, and plus p call and p. Man, they have flipped it. This guy has flipped it. Cell height times row plus p row. Okay, then we check if a non-color key pixel is found, then we set current char dot x equals p of x. Okay, and then we break the loop. Okay, then we okay, so we are basically updating the width, height, x and y. Okay, here we go. If non-color key pixel is found, if a non color, if a non-color key pixel is found, so if pixel. Within that pitch, within that pitch. Okay. So get pixel is not equal to background color. Okay. Texture get pixel 32. BMPF texture, comma, equal to PG color. I have to find PG color, right? Yeah, okay. It's not defined, it's not equal to, then we set the X offset. So we go BMPF cas dot X equals P of X. For each cell we need to go through all the pixels in the cell to find the edge. Okay, we find the left side of the cliff, we set X position, breaks the loop, go find the right side, and that will be the width, right, pixel, and we want to find this plus 1, so this up to this. Go find the right side. So, and then we have get the pixel offsets, same. Okay, so we are starting from the left side. Okay, so goes to cell width -1, and it should be greater than equal to 0. And we are decrementing it. If we go through the pixel rows, starting from the right side, and this is cell with time call plus this is what p call, right, call width, it doesn't matter. Okay, p row width, and we check if a non-color key pixel is found. Did we break the loop here? Yeah, I didn't break the loop. Okay, so breaks the loop, p col equals, but I'm never going to use p col and p row again, right? Okay, have I declared p col and p row? P row w, p col. So I can just break the loop, you know. Okay. हाँ से बोलो हेलो हेलो हाँ बाबा को भेजो हाँ खाना खा के आएंगे बाबू कभी बाबा भी खाना खा रहे हैं Okay, so right, okay, so breaking the loop by going beyond the limits by setting the condition false. Okay, so we go p col equals cell width and p row equals cell height. Right, okay, that's how you break a loop. Set the, okay, if the non-color key pixel is found, if non-key color pixel is found, so if texture get pixel 32 share comma px py not equals to bg color, and we set the width bmpf chars current char dot width equals to px minus the x, okay, and plus 1. Okay, got it. So we are basically doing this pixel minus this pixel plus 1 for the width, right? Okay, so we go px minus bmpf chars and current char dot x plus 1. Set the width, break the loop. So I'll go p color w equals -1 and then p row equals cell h Okay, this will break the loop. Now then, here we're looking for the pixel on the right side. It works pretty much the same as finding the left side. Only uh, only we're moving from the right. We're moving from the right to the left instead. It's left to right. To find the pixel, we use it to set the width. Since the pixel area starts at 0, we need to add 1 to the width. Okay. So find top. Start at the top. If P of row is less than top equals to P row is less than top. Okay, so we have set top to be the height, so it is the bottom pixel. Right now, if we set that P row is less than top, then we have found the top pixel. Okay. Okay, current char equals A. So base A, find the bottom of A. If current char equals A, go through the pixel and we get this. Go to the next character. Okay, in terms of looking for the bottom of the clips, the only thing we care about is capital A. For this bitmap font builder, we're going to use bottom of the sprite as the baseline for characters like J, Y, etc. that hang below the baseline. Don't define the bottom. You don't have to do it this way, but it's given me good results before.